Right, Hamza?
Yes, sir.
So we are beginning with unit number 3 called Kinematics, and now I have decided that I'll give you the introduction of kinematics in written form. So that's why I'm not going to introduce it. Are you there, Hamza?
Yes, sir.
But your two profiles are appearing, Hamza. Well, unit number 3 kinematics was being started in the older days of physics, in the starting days of physics, but the kinematics of those days and kinematics of today are much different topics. Because in today's kinematics, we are not only dealing with the motion of the daily life objects, with the movement of objects in daily life only, but we are also dealing with the motion of particles like electrons around the nucleus, and we're also dealing with the motions of objects like planets in the solar system around the sun. We are also dealing with the spins, with the movements of galaxies, and we are also dealing with the movements of universe, with the movements of galaxies, and the movement called expansion of universe also. So there are so many different types of movements which are being involved in today's topics of kinematics, but obviously we have to follow the syllabus outlines. So as far as your syllabus outlines are concerned, I'm beginning with the sentences written in your syllabus, and these sentences are: kinematics is the study of motion. Movement is part of everyday experience. So it is important to be able to analyze and predict the way in which objects move. And if we are analyzing and then predicting, as an example, just suppose we have analyzed that how electrons of hydrogen atom, how electrons around the nucleus of an hydrogen atom do move, and if once we'll have a successful analysis, then we can also predict the way with which the electrons around the nucleus of helium atom or around the nucleus of any other element of periodic table are moving. So once the analysis is being done, then we can also predict by applying that particular analysis, by applying the mathematical expressions obtained in that particular analysis onto the similar movements or to the similar other movements of other objects, and in this way we can predict so much about the future, so much about the new objects. The behavior of moving objects is studied both graphically and through equations of motion. So I am beginning with the sentence of your syllabus. Candidates should be able to define and use distance, displacement, speed, velocity, and acceleration. And I have picked all those definitions. I have tried to pick all those definitions from the examiner reports or marking schemes of your CAIE previous year's past paper examinations. So first of all, I am beginning with the definition of distance, definition of displacement, and then the distinction between distance moved and displacement. So do you have any idea, Hamza, what is distance?
Sir, distance is the length between 2 points.
Oh, yes, the length moved, the length covered between the 2 points, between the point of start and the point of destination. The particular path which is being followed is called a distance. I have seen at your levels, people are not bothering about the definition of distance very much. So that's why they are more bothering about the distinction between distance moved and displacement instead of the definition of distance moved and displacement. But since but even then we should know the definition of distance moved and displacement. Okay, so distance is the length moved between 2 points, length covered between 2 points, length traveled between 2 points, and displacement is the distance covered in a specified direction. Am I right, Hamza?
Yes, sir.
So, what is the difference between these two? What is the difference between the distance moved and displacement?
So the distance will be the total ground covered between and point A and point B. But displacement will be the straight direct distance in a straight line between points A and B.
Well, distance is a scalar quantity and displacement is a vector quantity. Just suppose if we want to travel from point A to point C, but in order to travel from point A to point B by road, the only two roads are available. First, the road is moving or is connecting point A with a certain point B, and then the second road from the point B is going to connect us with the point C. So the total distance traveled, just suppose from A to B, from A to B, the distance traveled was equals to 15 kilometers, while from B to C, the distance traveled was equals to 13 kilometers. So 15 plus 13 equals to 28 kilometers will become the distance traveled by us by road. Now, Hamza, beta, if a helipad is available at point A and another helipad is available at point C, then we can straight away fly through the helicopter in a straight direction from point A to point C because helipad is available and we can take the aerial route instead of following the route on the road. And this aerial route is not of 28 kilometers, maybe it is just of 15 kilometers or 13 kilometers or 17 kilometers on because we are going straight. So displacement is actually the distance moved in a specific direction while the distance moved is basically the length covered. Is it clear, Hamza?
Yes, sir.
Right, G. I have said distance moved or distance is the scalar quantity and displacement is the vector quantity. Another scalar and vector quantity difference lies between the definitions of speed and definition of velocity. Speed is the scalar quantity and velocity will be the vector quantity. I have also quoted here the definitions according to your examiner reports and marking schemes. So try to follow or try to convert this mathematical expression into English language and tell me what is speed and what is velocity, Hamza.
So speed is the rate of change of distance, and velocity is the rate of change of displacement.
Okay, right. The speed is the change in distance per unit time, and velocity is the change in displacement per unit time. So these definitions are being taken from your examiner reports and marking schemes. So please try to stick only with those words which are written in the marking scheme and examiner reports. Once we'll start practicing the past paper questions. And acceleration will be the change in velocity per unit time. The people had studied it in basic classes that acceleration is the change in velocity per unit time. And what was the expression which was being obtained by us by converting this English language into mathematical language? What is the mathematical expression of acceleration, Hamza?
Meters per second squared.
Yeah, that was the unit. That was the SI unit of acceleration. As far as the mathematical expression is concerned, we can obtain it mathematically or by applying the unity mathematics simply.
So v minus u over t.
Yes, small a equals to v minus u over t. Actually, if in time t, the change in velocity is equals to v minus u, where v is the final speed while u is the initial speed of the moving body. So if in time t, the change in speed is equals to v minus u, then the change in speed by dividing with time can be converted into the change in speed per second. Are you agreed, Hamza?
Yes, sir.
So v minus u over t will become the magnitude of acceleration because I have used the word speed here. Okay? So a
Yes,
equals
sir.
to v minus u over t is actually giving us the magnitude of acceleration, but as acceleration is a vector quantity, so we need to speak the change in velocity per unit time because velocity also covers the aspect of direction. Right, Hamza?
Yes, sir.
So A equals to V minus U over T can give us the magnitude of acceleration, while we need to specify a particular direction in order to calculate the complete value of acceleration, because acceleration is a vector quantity and we need both magnitude and direction in order to completely study it, in order to completely understand it, in order to completely present its value. Are you agreed, Hamza?
Yes, sir.
I have also taken the definitions. Displacement is the distance from a fixed point in a specified direction. And by the help of the vector version of distance covered, we can define what is displacement. And displacement is actually the distance moved from a fixed point in a specified direction. And if we have added direction or a specified direction in distance, and it becomes displacement. We have added specified direction in the definition of speed, and it becomes velocity. Are you agreed, Hamza?
Yes, sir.
Right, G. I've also taken this definition from your ex-post papers. As an example, this is being taken from November 2018 paper, from paper 2-1, question number 1, and the answer is acceleration can be defined as the change in velocity per unit time, or the rate of change of velocity, which you were saying a little bit ago. The meter m is the unit of length. You know, the SI unit of meter is the length. Hamza, I am moving quickly. Is it okay? I have not spoken about the meter per second square. I have not spoken about the meter per second, but I think you have an idea about meter per second square.
Yes, sir.
And you must know also how have you obtained both. Meter per second was being obtained as an SI unit from the mathematical expression V equals to d over t. Speed equals to distance over time. In numerator, we have substituted meter in place of distance, and in denominator, we have substituted second in place of time, and this way we have obtained meter per second. Okay?
Yes, sir.
So speed has an SI unit, meter per second. Acceleration has a has an SI unit, meter per second square. So now from here onwards, you should realize that every quantity related with every quantity, we need to learn four different concepts, or four concepts should be related with every quantity. As an example, you should always realize that acceleration, ACCELERATION, acceleration is the name of a quantity, while small a is the universal symbol or usual symbol which is being suggested, which is being used in place of the complete word acceleration. Are you with me, Hamza?
Yes, sir.
Similarly, the SI unit of acceleration will be meter per second square, while B, as the name is meter per second square, METER, PER, SECOND, whole square, meter per second square. While in symbols, in the form of symbols, we can write it meter into small s, small m into small s, raised to the power minus 2. Is it okay?
Yes, sir. And sir, the velocity will be v and speed will be s.
Velocity will be v. Yes. Uh, I'll send you the list. I'll send you the list of the symbols which are being used by your syllabus booklet, because I have not seen the symbols which are being used by your new booklet. But I'll sooner send you the complete list of the symbols which are being used by your syllabus booklet. Okay?
Okay, sir.
So then, whatever symbol will be suggested by your examiner, you have to use that particular symbol. And another way to know which symbols are being suggested by your examiners and which symbols are not being suggested by your examiners, the best way is to study the answers of the past paper questions from the marking schemes and from the examiner reports. This is the best possible way. In this way, you came to know that which symbols are being suggested, which symbols you should use throughout the syllabus for any quantity. Right,
Sir, I
Hamza?
found them. I found them there in the syllabus.
Louder, better?
Sir, I found them there in the syllabus at the end.
Okay, then definitely you can use it. Because I am used to consult, I have to consult so many different books of different levels. So that's why I can make a mistake. I can make a mistake. Maybe I'm going to use the symbol for distance covered, which is not being suggested by CAIE. So you need to follow the symbol suggested by CAIE. Okay?
Okay, sir.
Right. So the meter m is the unit of length and is equal to the path traveled by light in a vacuum during the time interval of 1 over 3.0 into 10 to the power 8 of a second. So this is approximately being taken, exactly being taken. They have tried to take the exact value, which is 299792458. Actually, this value is approximately 3.0 into 10 raised to the power 8, Hamza,
The speed of light.
which is the speed of light. Okay? So
Yes, sir.
please, this definition is easy. Try to understand this definition. If you want be, if you will not be, then ask me a question and I'll explain it next time. Okay? I'm moving ahead at the present moment.
Okay, sir.
Right. Because we want to finish the starting chapters as early as possible. Now, here my intention is that I want to give you the revision concept. I want to make your concept revised about the graphs, and particularly the two graphs which are very important in this chapter of kinematics. The two graphs or the four graphs which are very important, which you people have already studied in your O level classes, are distance time graph, displacement time graph, speed time graph, and velocity time graph. Agreed, Hamza?
Yes, sir.
So I'm beginning with the distance time graph. And you can see that distance is being plotted on the y-axis and its symbol used is small s, while time is being plotted on the x-axis and its symbol which is being used here is small t. Are you aware of the fact independent variable and dependent variable?
Yes, sir.
So time is an independent variable while distance is the dependent variable which depends on the value of time. So I can decide that after some fixed intervals of time, I'm going to notice the distance covered by any moving object. And then by plotting all those values, by tabulating all those values in a table, finally, when I have plotted the graph which is being obtained, the graph of distance against time, which is being obtained by the help of the data, tabulated data recorded for a certain body which is actually moving a distance covered, is a straight line, and that straight line is passing through origin also because 0 0 is being given here. So Hamza, if I'll give you a graph, a distance time graph of a certain body, certain moving body or a certain object, and that graph is a tilted straight line, the line which is making some angle with the x-axis, the line which is making some angle with this y-axis, if that particular tilted line is passing through the origin also, so what can you say about the movement of that body? Is that body moving? Is that body covering distance?
Yes, sir.
How do you know that the body is covering or moving distance whose graph is being plotted here by us? How do you know?
Sir, because the both quantities are changing proportionately. If it were parallel to either of the axes, then there would be no movement.
But at the present moment, our straight line is a straight line, but it is not parallel to x-axis or y-axis. At the present moment, this particular straight line is tilted. This particular straight line is making a slope which is non-zero value, slope having a non-zero value, making some angle with the x-axis. So clearly we can notice this as the time is passing from left to right, you can clearly see the distance from the origin is also being increased. The distance from the reference point, actually the origin is in the graph, but that there is a particular reference point in the city about which is being fixed by us. As an example, we can fix that Beacon House Liberty Campus. Just suppose Beacon House Liberty Campus is the reference point, is the 0 point of the city of Lahore, right?
Yes, sir.
And we can divide the whole Lahore into four equal portions: north, according to north, south, east, and west. And the origin and the lines where the two lines are crossing, where the two graph lines are crossing each other, exactly lies on Liberty campus. So Liberty campus is being taken in the city of Lahore. So whatever is traveling in the direction of north from the reference point is being taken as the positive displacement, and whatever is being moved in the south of Lahore from the origin point is being taken as negative displacement. So are you with me, Hamza?
Uh, so can you please repeat that?
Actually, I'm going to use that particular concept when I'm going to plot the displacement time graph. At the present moment, I am plotting, or we are dealing with the distance time graph only, in which all the distances which are being covered can be taken as positive. So the distance covered in the direction of north, or distance covered in the direction of south, from the reference point, from the 0 point, which is our reference point, which is being taken as MM Alam Road, which is being taken as a point on the MM Alam Road, just suppose, and we have divided Lahore into two equal portions, right?
Yes, sir.
So any distance covered, whether it is in the direction of north or whether it is in the direction of south, can be taken as a positive distance covered for the time being, because at the present moment we are dealing with distance time graphs, not displacement time graph. Right, Hamza?
Yes, sir.
Later on, I'll tell you about displacement time graph also. So this object is covering distance from the reference point. Reference point, when the suppose the object was already present in a Liberty campus at the MM Alam Road, Beacon House Liberty campus, MM Alam Road. Initially, the object was present at that particular point, which is being taken as origin by us. Now the object is traveling in a direction of north. Suppose it is traveling in the direction of north, or object is traveling towards north above then east-west line. Is it okay?
Okay, sir.
Right, G. So its graph is being plotted. You can see as the time is passing by from left to right, the distance covered by the moving object is increasing and further increasing, right?
Yes, sir.
And can I say, Hamza, that this distance covered by the moving object is equal in equal intervals of time?
Yes, sir.
How can I say the distance covered? How can I say by simply watching the graph, by simply seeing the graph, distance covered by the moving object is equal in equal intervals of time? How can I say?
So since the gradient is not changing, we can say that all the increase in distance is linear.
You want to say it is a straight line?
Yes, sir. Since
Yes,
there
it
is,
is a straight line. And straight line graph can only be obtained when the equal distance is being covered in equal intervals of time. So it is absolutely clear by the help of this straight line graph that that particular object for which we have plotted this graph was covering equal distances in equal intervals of time. So that's why this is a straight line. Right, G. From this graph, we can obtain the information of distance covered from the y-axis. From this graph, we can obtain the information of time from the x-axis. But how can we obtain the information of speed or velocity from this graph, Hamza? Is it possible to obtain the information of speed or velocity from this graph?
so we can obtain the speed, but not the velocity. We can only uh, find find the velocity if we have if the direction is given. The speed will be the gradient of this graph.
Yani, you are saying that we need to calculate the gradient of the graph in order to calculate the speed or velocity of the graph.
Yes, sir.
Then what is gradient, Hamza?
So it will be distance over time
The gradient
of
of
the
the
graph.
graph will be the
The slope of the graph rise over run.
actually rise over run is the language which is usually being used by the mathematics teachers. But here in physics, we need to talk about some technical definitions, some sound technical definitions. Although this will be a part of my lecture number 3, but I am introducing this definition of a gradient with the point of view of physics books right here to try to understand it better. Okay, as far as our physics concept is concerned, we used to say that mathematical term y2 minus y1 over x2 minus x1. You used to calculate the gradient by the help of formula. Gradient of the graph or slope of the graph is actually equals to y2 minus y1 over x2 minus x1. Okay, Hamza?
Yes, sir.
This y2 minus y1 will be named by us, the physics teachers, as the change in the quantity which is being plotted on the y-axis, right?
Sir, I need to understand this part.
I'm repeating, y2 y1, y2 minus y1 will be named, will be defined by us, the physics teachers, as the change in the quantity which is being plotted on the y-axis for
Okay,
any
sir.
graph. For any graph. Okay, Hamza?
Yes, sir.
And x2 minus x1 will be defined by us, will be named by us, will be introduced by us, will be elaborated by us, the physics teachers, as the change in the quantity which is being plotted on the x-axis for any graph. Is it okay, Hamza?
Yes, sir.
Right. So if y2 minus y1 is the change in the quantity which is being plotted on the y-axis, if x2 minus x1 will be the change in the quantity plotted on the x-axis, then definitely y2 minus y1 divided by x2 minus x1 will be defined, will be elaborated as change in the quantity which is being plotted on the y-axis per unit change in the quantity which is being plotted on the x-axis. Because x2 minus x1 is dividing y2 minus y1, just like as in case of speed, time was dividing distance. Hamza, when time do divide distance, speed equals to distance over time. So we
Yes, sir.
said distance per second. हमने कहा था ना वहां पे
Yes, sir.
distance per second. So I am saying here y2 minus y1 is being divided by x2 minus x1. So that's why I can say, I can use the term the change in the quantity which is being plotted on the y-axis per unit, because x2 minus x1 is dividing in the denominator, per unit change in the quantity which is being plotted on the x-axis. Right, Hamza?
Yes, sir.
This will be a part of my lecture number 3, inshallah. I'm going to speak the further details about it, but at the present moment, I'm simply introducing the gradient of any quantity, gradient of any graph will always be the change in the quantity plotted on the y-axis per unit change in the quantity plotted on the x-axis. By applying this explanation in the present graph, so we are talking about the gradient of distance time graph. So it means the change in the distance per unit change in time. Are you with me, Hamza?
Yes, sir.
The change in distance per unit time is actually being regarded as speed. Isn't it like that, Hamza?
Yes, sir.
So that's why we are naming that the gradient of speed time graph, sorry, the gradient of distance time graph will be the speed of the moving object, or the information of speed of the moving object can be obtained by simply calculating the gradient of the distance time graph of the moving object. Is it okay?
Yes, sir.
Right, G. So we can also obtain the information of speed by the help of this particular graph. So I have also plotted another graph here. This graph is actually about a moving object A and moving object B. These are the two graphs, moving
Yes, sir.
object A, moving object B. Both graphs are covering equal distances in equal intervals of time, because both graphs are straight line and passing through the originals. So both graphs are covering equal distances in equal intervals of time. Are you agreed, Hamza?
Yes, sir.
If this graph is of the moving vehicle, moving object B, and this graph is of the moving vehicle or moving object A, What can you say about the speeds of A and B?
As so A has a higher speed than B.
This was A,
Oh, so I
this
said B
was
has a
B.
higher speed than A
How do you know that B is a high speed than A?
because B is covering more distance per unit time than A.
Shabash, yes, this can be an answer. At the present moment, you can also say that because the gradient of the graph of B is more steeper.
Yes, sir.
The gradient, the slope of the graph is more steeper. It's a steeper graph. The slope is higher, the slope is larger. So that's why this particular object was actually moving with a higher speed. It must be moving with a higher speed. That's why such kind of data is being obtained. That's why such kind of graph is being obtained. Such kind of graph whose or its gradient is larger as compared to the gradient of A. Okay, Hamza?
Yes, sir.
So you can see that the distance time graph is also giving us the information, is also giving us the information about the speed of the graph. Now we need to interpret this particular graph also. Somebody has plotted that graph and given it to us. We need to interpret it. And this time we can clearly see that there is a object whose graph is obtained as from the given data, from the obtained data, from the calculated data as a straight line which is parallel to the x-axis, not overlapping x-axis, but this particular straight line is parallel to the x-axis. What does it mean, Hamza?
Sir, this means that the object covered it was at a specific distance from the origin at time zero, and it has not moved.
The object is not moving.
Yes, sir.
Okay, so why are you talking about that it is covering some distance, or it is covering some distance, or it has covered some
It has
distance?
covered. It has covered. It was.
Obviously, yes. When we have started our stopwatch, we don't know how. Just suppose that this particular reading is 20 kilometers. Just suppose this particular object is 20 kilometers away from the reference point when we have started our stopwatch. Is it okay, Hamza?
Yes, sir.
So we have checked that time is passing by. We have taken 5 to 10 readings and we have checked that time is passing by, but the object remained at 20 kilometers position away from the reference point. So that's why we can say the object was not moving. Its graph is a straight line parallel to x-axis. Now tell me, Hamza, if I'll give you the graph which is overlapping x-axis, which is overlapping time axis, then what will be it means?
So that
I
the
can also
object
give
is
you a
not moving.
graph. I can also give you a graph to interpret. And the graph is, it will be a horizontal line, horizontal straight line overlapping the time axis. Then
So
what do you say?
it has not moved from the zero from the origin.
The object
And
is at rest at the reference point of the city.
yes, sir.
Okay? Then we'll say the object is at rest at the reference point of the city, whatever will be the reference point of the city. Now, next, we have another graph, and I have written a note along with it. The slope of this graph suddenly becomes negative. The object is moving back the way it came. Its velocity v is negative after time capital T. From 0 to capital T, some time is being passed. And after that, the straight line is moving in the downward direction, or straight line is being plotted in the downward direction. Straight line is not moving. I'm sorry. Straight line which is being plotted on the graph is being plotted in the downward direction. So, from your knowledge of mathematics, Hamza, you know it very well that this particular gradient or the value of this particular gradient will be obtained as a positive value.
Yes, sir.
And if you will plot and if you will calculate the gradient from the given values of such kind of line, you will obtain a negative value. Do you agree with that?
Yes, sir.
Okay, so that's why we are saying, your examiner is saying, your teacher is saying here that this particular line is a positive gradient line and this particular line is a negative gradient line, because whenever such kind of lines, whenever the data of such kind of lines is being used to calculate the gradient, we'll always obtain the negative values. So that's why such kind of lines are called the negative gradient value lines. Okay, Hamza?
Yes, sir.
Right, G. Now, the graph which is being plotted for an object, which was first initially traveling from 0 to capital T seconds and then from capital T onwards. So, what can you say about the movement from 0 to capital T seconds?
Say that it was moving away from the origin
It was
or the
moving,
reference point.
it has started its journey. It has started its journey from the reference point of the city. Okay.
Yes, sir.
It was covering equal distances in equal intervals of time.
Yes, sir.
It was moving with the constant speed. How do I know it was moving with the constant speed, Hamza?
So it has been moving as at a constant state because the gradient does not change. The gradient remains constant, and speed
Because
is
it is a
decreasing.
straight line, because it is a straight line graph, and already we said about the straight line graph that the object is covering equal distances in equal intervals of time. If any object is covering equal distances in equal intervals of time or equal distances per unit time, we used to say that particular object is moving with constant speed. So it is absolutely clear that this particular object was moving with a constant speed, so its graph is being obtained as a straight line from the origin up to that point. But what has happened at that point, okay, straight line which is being plotted next is falling down, next from capital T second. What can you guess, Hamza? What has happened actually?
So it has now moving towards the. It moves backwards towards the origin,
Okay,
and then comes to
okay,
a stop.
shabash, shabash, shabash. If we have taken the reference point of the city as the roundabout of Liberty, just suppose if we have taken the reference point of city as the roundabout of uh, Liberty, which is in front of Gaddafi Stadium. So just suppose if we have taken our reference point as the roundabout of Liberty, so it clearly means, or it means that initially the object was moving away from Liberty roundabout in a certain direction, and now after traveling for time capital T seconds, now it is coming back towards the reference point once again. Now it is coming back towards the Liberty roundabout once again. So it is becoming closer to the reference point or Liberty once again. And both graphs are being plotted one after the one. So that's why from capital T onwards seconds, for the time which is capital T plus seconds, we need to plot a graph which is falling in the downward direction. Now, any question, Hamza?
No, sir.
Shabash, shabash, you're picking up. Our next graph is a curved graph, beta. It's not a straight line. And I have written the note here that the displacement time graph is curved. The slope is changing. This means that the object's velocity is changing. This is considered in chapter number 2. I have taken it from a certain reference book, and in that particular reference, they have uh, pended it for chapter number 2. But it's not difficult one. We are going to do it right here. So, what does it mean, beta? What is being shown by this graph? How can we interpret that particular graph?
Sir, we
Acha, okay, my first question is, was that object covering equal distances in equal intervals of time?
in this curve graph.
Yeah.
No, sir, because the gradient is constantly changing.
Oh, yes. This, the data which is being obtained from the movement of the moving body, of the moving object, the data which is being obtained, that particular data is being used in order to plot that graph. So it is impossible that that object was covering equal distances in equal intervals of time. That object must be covering unequal distances in equal intervals of time, or unequal distances per unit time. Can you tell me whether it is the increasing gradient graph or a decreasing gradient graph, Hamza?
So it is a decreasing gradient graph as the uh, line is becoming flatter towards the end.
Shabash, this can be the recognition. We can say, yes, this is the decreasing gradient graph because the line is becoming flattened in the end, or line is trying to become parallel to the x-axis. Graph line is trying to become parallel to the x-axis in the end. But typically or correctly, we need to say that object is covering. Please listen it very, very carefully. The object was covering less distance in less distance in every equal interval of time, in every next equal interval of time. I repeat, the object is covering lesser distance, Hamza. The object is covering lesser distance in every next equal interval of time. I can make five different equal intervals on this graph, five different equal intervals of time on this graph. Interval 1, interval 2, interval 3, 4, and 5. And I am trying to say the object was covering or has covered less distance in the second interval of time, in the second equal interval of time, as compared to the first equal interval of time. Are you agreed with me, Hamza?
Yes, sir.
And similarly, the object has definitely covered less distance in the third equal interval of time, equal to 1 and 2, interval 1 and 2. And similarly, the object has definitely covered less distance in the fourth equal interval of time, the fourth interval which is equal to first, second, and third interval. And the object has definitely covered less distance in the fourth equal interval of time. And finally, in the last fifth equal interval of time, the object has covered the least distance as compared to the interval number 1, 2, 3, 4, and 5. So such kind of movements always generate data with which, if the graphs are being plotted, then the graphs will definitely be of decreasing gradient. Agreed, Hamza?
Yes, sir.
So this is a decreasing gradient graph. The object is covering unequal distance in equal intervals of time. The object is covering lesser distance in every next interval of time. So what can I say about the speed of the moving object, Hamza?
So it is decreasing.
Well, speed is changing, huh?
Yes,
And
sir.
later on, and later on in the next chapters, we'll see the speed is decreasing or increasing. Okay?
Okay, sir.
Oh, you were correct. You were correct. But we are not dealing it in details right here. We will deal the details of it later on, inshallah.
Sir, but the main point of this graph was that the less distance is covered at each time interval from the start.
The